So as I said previously, this is not a terribly good alignment. So I prefer to use another program to do the alignment, because Clustal W is somewhat outdated and definitely not the best that you can possibly use. So what I'm going to do is use muscle, and also after that I'm going to use Clustal Omega. So I'm going to assign a new object, which is a new alignment. So MSA, I'm still using the same sequences as before, HA-seq. And now I do a comma and I can specify which particular program I'm going to use. So I'm going to use muscle. So I've added that to my scripting file so that I've got it ready for the future. Now if I go to this window and click on help, I can find out about MSA. So the function MSA has inputs being method equals, oops, I need to say method equals muscle. So you've got the input sequences, which is HA-seq, you've got comma, I can give it a space there, method equals, so in this case you can use all, this is going to use all of those at the same time, but it doesn't matter. Then you can specify parameters for gap opening, gap extension, if you wish to have a different gap properties, and you can also change the substitution matrix. Let's look at what substitution matrices we can use. So it depends on the program you're going to use. So I'm using muscle, so which gap opening is 400 for DNA. Gap extension penalty, the default is 0. The substitution matrix is can be assigned as a real matrix or a name of a particular one that you want to import. So we're going to have to leave those all as defaults to start with, and let's see what happens. So I put that code in there, and to run it, put my cursor at the start of the line, and press the run function. Assuming DNA, see sequence type, invalid letters found. This happens because sometimes when you get sequences, there are other characters, and I suspect that that might have some dashes from a previous alignment in it, because when I did the edit to get the start code on, I needed to do a preliminary alignment to get it in the right format. Now let's see what, if I look at the environment, I've got this HA alignment muscle, so I can have a little look at it and use the same print statement that I used before. So I'm going to Control C, Control V, but then change it so that it works on the muscle one. Oops, underscore muscle. So I can then run this, then save it, and then run that particular line, and it shows me the alignment. Okay, so the actual troublesome character looks like it's N. It's very annoying that the databases contain a lot of N's, meaning there is a nucleotide there, but we don't know what it is. Now this alignment looks a lot better, at least it starts with ATG. Now looking at this, 1, 2, 3, 4, 5, 6. So that's okay. That's an insertion of a gap of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is bad because it's 2. This is okay because it's 3. If you end up with gaps and they are not a multiple of 3, then what you would do is change the codons. So you would change the codon alignment when you're translating from the DNA to the amino acid. So what you're looking for when you're looking at a DNA alignment is gaps which are 3, insertions which are 3, and to avoid ones which are 1 or 2. So 3, 6, 9, fine. Other ones, not so good.